The story unfolds by opening on an unexpected deep space detection tied to 3I/ATLAS, then rewinds to explain how the object was first noticed, how data anomalies emerged, and why scientists initially dismissed them. It escalates through mounting confirmations from multiple observatories, introduces a second, massive presence emerging from deeper space, and explores its strange behavior and apparent alignment with 3I/ATLAS. The narrative then shifts into global reactions, internal debates within the scientific community, suppressed findings, and unsettling implications about intent, intelligence, and cosmic surveillance. The final movement reflects on humanity's psychological reckoning, the fragility of certainty, and the haunting realization that the universe may be far more aware of us than we ever imagined. Something massive appeared without warning, not as a flash or explosion, but as a distortion in data so subtle that it almost slipped through unnoticed, buried beneath routine celestial noise that astronomers process every night. It emerged from a region of deep space so dark and cold that most surveys treat it as background emptiness, a place where nothing of consequence is supposed to move, let alone announce itself. The first sign came as a timing discrepancy in the tracking of 3I/ATLAS, the interstellar object already puzzling scientists with its unusual trajectory and non-gravitational acceleration. At first, the deviation was blamed on calibration drift, a minor software hiccup, or perhaps solar radiation pressure miscalculations that had not yet been fully corrected. But when independent systems in different hemispheres recorded the same discrepancy, the quiet assumption of error began to feel less convincing. 3I/ATLAS was no longer behaving like a lone traveler, and the math hinted that something else was influencing its path from far beyond the edge of the solar system. Deep space radar arrays were tasked with a closer look, sweeping the darkness with long integrations that pushed instruments to their operational limits. What came back was not an image, but a mass estimate inferred from gravitational effects, and that estimate was uncomfortably large. Too large to be a comet, too massive to be a rogue asteroid, and far too coherent to be dismissed as a statistical artifact. As analysts refined their models, a second object began to take shape in the equations, not visible in reflected light, but undeniable in its influence. It appeared to be moving on a vector that intersected the path of 3I/ATLAS with unsettling precision, as if the encounter were planned long before our telescopes ever existed. The object's velocity suggested an origin far outside our galactic neighborhood, from a depth of space rarely associated with structured motion. Unlike typical interstellar visitors, this one showed no signs of tumbling chaos or random drift. Its course was steady, deliberate, and smooth. Whispers spread through research teams, cautious phrases replacing bold claims, yet the tension in every meeting room grew heavier by the hour. When infrared data finally hinted at a faint thermal signature, the room fell silent because the heat profile made no natural sense. It was too uniform, too controlled, lacking the gradients expected from a body warmed by stars or radioactive decay. Someone suggested a dust-shrouded brown dwarf, but the mass didn't align, and the luminosity was all wrong. Another proposed an ancient stellar remnant, yet its motion contradicted everything known about such objects wandering alone. As data stacked up, the uncomfortable word targeting began appearing in internal notes, never spoken aloud, but impossible to ignore. The massive object was adjusting its course, not toward Earth, but toward 3I/ATLAS itself, matching changes with eerie responsiveness. Every time 3I/ATLAS altered its trajectory slightly, the distant mass compensated, maintaining a constant relational geometry. This was not passive gravity, it looked like pursuit, or at the very least, coordination. Requests for additional observation time flooded observatories worldwide, some approved instantly, others quietly delayed without explanation. Behind closed doors, discussions turned philosophical as much as scientific, touching on intent, agency, and the limits of accepted theory. Publicly, officials reassured that nothing unusual was occurring, that interstellar dynamics are complex and often misunderstood. Privately, simulations ran non-stop, each one ending with the same conclusion that no one wanted to put in writing. The object was massive enough to be detected if it wanted to be, yet it remained cloaked, as though aware of how to stay hidden. Its lack of visible outgassing, flaring, or debris suggested a structure, not a natural aggregate of rock and ice. One senior astrophysicist resigned abruptly, citing personal reasons, though colleagues knew he had argued fiercely against releasing any preliminary findings. Rumors leaked anyway, spreading through academic circles and then into the wider public in fragmented, half-understood forms. Online forums lit up with speculation, some dismissing the idea as sensationalism, others sensing that something fundamental was shifting. As weeks passed, the object drew closer to 3I/ATLAS, their paths weaving a silent dance across the star charts. No radio emissions were detected, no laser flashes, nothing that could be interpreted as communication. And yet, the precision of the interaction felt communicative in itself, like a language written in gravity and time. Theories multiplied, from exotic dark matter constructs to relics of pre-galactic civilizations drifting between stars. A few voices dared to suggest that 3I/ATLAS might not be the anomaly, but the bait. That idea was quickly buried under layers of cautious wording and peer review delays, but it lingered in the minds of those who had seen the raw data. As the massive object crossed a threshold distance, subtle perturbations reached the outer planets. Barely measurable, but undeniably present. Space agencies coordinated in unprecedented ways, sharing classified telemetry that would normally never leave secure servers. The realization settled in that humanity was not observing a random event, but witnessing an interaction that had begun long before we noticed. Historical data was reanalyzed, and faint hints emerged that similar disturbances may have occurred centuries ago, unrecognized by less precise instruments. If true, this would mean such encounters are not unique, merely rare and fleeting, passing beneath the awareness of young civilizations. The object's mass estimate was revised upward again, pushing it into a category that defied easy classification. It was not a star, not a planet, and not a cloud, but something in between, compact and controlled. As tension grew, cultural reactions mirrored scientific unease, with art, literature, and media reflecting a collective sense of being watched. Religious leaders offered interpretations ranging from cosmic indifference to purposeful design, each grappling with the same unknown. Meanwhile, 3I/ATLAS began to exhibit changes of its own, shedding material in patterns that looked almost symmetrical. This shedding did not slow it down. Instead, it altered its spin and orientation, as if responding to an external signal. The massive object adjusted again, maintaining its relative position, never colliding, never retreating. At a certain point, analysts realized that Earth lay outside the immediate interaction, not ignored, but irrelevant. That insight was both comforting and terrifying, suggesting that the universe hosts dramas in which humanity is merely an observer. Still, the possibility remained that observation itself was part of the equation, that awareness might matter in ways not yet understood. As the objects drew closer together, data streams became erratic, instruments overwhelmed by gravitational complexity. Some readings simply vanished, overwritten by noise that could not be filtered out. When the two finally reached their closest approach, there was no explosion, no flash, no visible exchange. Instead, 3I/ATLAS altered its trajectory sharply, as though released from an invisible constraint. The massive object slowed, its course bending away, retreating back toward the dark from which it came. In the aftermath, scientists pored over terabytes of data, searching for meaning in what had not happened. No material transfer was confirmed, no energy spike recorded, yet the gravitational signatures told a story of interaction. It was as if a message had been delivered without words, an instruction given and received. Official statements framed the event as a rare but natural interstellar encounter, emphasizing the absence of danger. Few believed that explanation fully, but it was accepted enough to quiet public anxiety. In private reflections, many researchers admitted that the universe felt different now, less silent, less empty. The encounter forced a re-evaluation of assumptions about isolation and randomness on a cosmic scale. If such massive, coordinated phenomena exist, then intelligence or structure may be woven deeper into the fabric of space than previously imagined. 3I/ATLAS continued on its new path, no longer heading where predictions once placed it. The massive object faded back into undetectable darkness, leaving only equations and unease behind. Years from now, textbooks may mention this event as a footnote, stripped of its mystery and fear. But for those who watched it unfold in real time, the memory remains vivid and unresolved. They know that something massive appeared from deep space, that it targeted 3I/ATLAS with purpose, and that it left without explanation. And in the quiet moments between discoveries, they wonder if this was a singular event, or merely the first time humanity noticed the universe paying attention. The unanswered questions did not fade with time. Instead, they deepened, settling into the scientific community like a low, persistent hum that could never quite be ignored. Long after the massive object slipped back into the darkness, residual anomalies lingered in the data, small inconsistencies that resisted cleanup no matter how refined the models became. Graduate students assigned to routine follow-up analysis began reporting strange correlations that linked unrelated data sets across different observatories. At first, supervisors assumed pattern-seeking bias, the human tendency to impose meaning where none exists, especially after a dramatic event. But the correlations persisted even when stripped of context, emerging from blind analysis pipelines with no human input. The implication was subtle but unsettling. The interaction had left an imprint not just on trajectories, but on space-time measurements themselves. Clocks aboard deep space probes showed infinitesimal desynchronization, too small to matter operationally, yet statistically significant. No relativistic explanation fully accounted for it, and proposed corrections only introduced new discrepancies elsewhere. Some researchers began to quietly refer to the event as a handshake, a brief exchange governed by rules humanity does not yet know. Others rejected that framing entirely, insisting that anthropomorphizing the cosmos was a dangerous intellectual shortcut. Yet even they struggled to explain why the massive object had disengaged so cleanly once its apparent task was complete. 3I/ATLAS, now on its altered course, became a priority target for long-term monitoring, its every flicker scrutinized for hidden meaning. Spectroscopic analysis revealed subtle changes in its surface composition, as though layers had been stripped or rearranged. These changes did not match known space weathering processes, nor did they resemble damage from close stellar encounters. Instead, they suggested selective interaction, as if certain materials had been affected while others remained untouched. Requests to publish these findings met resistance from review boards urging caution and further verification. The word unprecedented appeared frequently in internal drafts, then vanished in later revisions. Outside the official channels, independent researchers attempted to reconstruct the event using publicly available data. Their conclusions varied wildly, but many converged on the idea that the massive object had exerted controlled influence. This notion sparked renewed debate about the limits of natural phenomena and the definition of technology on a cosmic scale. If something can manipulate gravity with precision, does it matter whether it was built or born? That question spilled beyond academia, seeping into philosophical circles and late-night conversations across the world. Art installations appeared depicting invisible giants brushing past fragile wanderers of stone and ice. Music compositions emerged inspired by orbital resonance and silent encounters beyond the stars. Humanity, it seemed, was processing the event emotionally, even as science struggled to process it intellectually. Governments maintained a careful balance, acknowledging ongoing research while downplaying speculative interpretations. Declassified memos later revealed that contingency discussions had taken place, not for defense, but for comprehension. What would it mean if the universe contains actors that notice some objects and ignore others? Why 3I/ATLAS, a relatively small interstellar visitor, had warranted such attention remained an open mystery. One hypothesis suggested that 3I/ATLAS carried something rare, perhaps information encoded in its structure or composition. Another proposed that its trajectory intersected a region of space significant for reasons unknown to us. A more unsettling idea suggested that 3I/ATLAS was itself altered long ago, marked in some way detectable only to certain observers. In that view, the massive object was not discovering 3I/ATLAS, but reacquiring it. No evidence conclusively supported any single theory, yet none could be entirely dismissed. As months turned into years, funding cycles shifted, and attention moved on to newer anomalies and discoveries. Still, a core group of scientists remained fixated, meeting quietly to compare notes and preserve institutional memory. They feared that without sustained focus, the lessons of the encounter would be lost to bureaucratic entropy. Occasionally, new data would reignite interest, a faint perturbation here, a timing offset there. Each time, excitement flared briefly before being tempered by uncertainty and competing priorities. The massive object itself was never detected again, not directly, not indirectly, not even as a statistical ghost. And yet the region of space from which it emerged remained strangely quiet, devoid of expected background noise. Some instruments registered that silence as an absence, others as a kind of saturation depending on calibration. It was as if the darkness there was not empty, but occupied in a way that defied measurement. This ambiguity became a metaphor for the entire event, something both present and absent, known and unknowable. Students who learned about the encounter years later encountered it as a case study in scientific humility. Professors emphasized not the answers gained, but the questions that remained stubbornly open. The encounter with the massive object and 3I/ATLAS did not revolutionize physics overnight. Instead, it subtly reshaped priorities, encouraging openness to ideas once considered fringe. It reminded humanity that observation does not guarantee understanding, and detection does not equal explanation. In quiet moments, some scientists admitted a lingering sense of being evaluated, though by whom they could not say. Not judged exactly, but noticed, cataloged, perhaps even dismissed as irrelevant. Others found comfort in the idea that the universe is active and structured, not indifferent chaos. Both reactions stemmed from the same realization. We are not alone in motion, even if we are alone in awareness. As 3I/ATLAS receded into the depths of space, its signal weakened, eventually blending back into cosmic background. The data archives closed, tagged, and stored, ready to be reopened by future generations with better tools. What remains is not proof of intelligence or intention, but evidence of interaction beyond expectation. Something massive appeared from deep space, engaged with a wandering interstellar object, and departed without ceremony. It did not announce itself, did not threaten, and did not explain. It simply acted, leaving humanity to infer meaning from shadows and equations. And in that silence, the most enduring change occurred, a shift in perspective that no dataset could fully capture. The universe, once thought to be a passive backdrop, now feels subtly responsive, not hostile, not welcoming, but aware in ways we are only beginning to imagine. Whether that awareness will ever turn toward us remains unknown. But the memory of that moment, when something targeted 3I/ATLAS with impossible precision, ensures we will keep watching the dark. Because now we know that sometimes the darkness moves first. Even after the last confirmed data packet faded into archival silence, the psychological aftershocks continued to ripple outward, reshaping how researchers interpreted every new anomaly that followed. Events once dismissed as sensor glitches were revisited with fresh caution, each one now carrying the faint possibility of intent rather than accident. Deep space monitoring protocols were quietly adjusted, extending observation windows and tightening thresholds for unexplained coherence. No announcement marked these changes, but within control rooms the atmosphere had subtly shifted from confidence to attentiveness. Astronomers found themselves lingering longer on empty frames, scrutinizing darkness itself for signs of structure. The idea that absence could be meaningful no longer felt abstract after what had transpired. A few theorists proposed that the massive object was not singular, but part of a broader class of phenomena that operate below conventional detection. In this view, the universe is threaded with slow, deliberate processes that intersect with visible matter only occasionally. 3I/ATLAS may have been one such intersection, a rare alignment that briefly lifted the veil. This interpretation reframed the encounter not as an intrusion, but as a routine operation from a higher-order system. If true, it would mean that cosmic events we label random are often anything but. The randomness then would belong to us, limited by perspective and scale. As this idea circulated, resistance grew, not because it lacked elegance, but because it challenged deeply held assumptions about causality. Science has long thrived on predictability, and the notion of unseen coordination threatened that foundation. Yet data does not care about comfort, and the data remained stubborn. Subtle statistical irregularities appeared in long-term surveys of interstellar objects, too faint to draw headlines, but consistent enough to raise eyebrows. A pattern began to emerge, one that suggested certain trajectories were favored, others avoided, not controlled in a mechanical sense, but nudged as if along invisible gradients. This led to speculation that space itself might host informational structures, shaping motion the way terrain shapes rivers. In such a universe, gravity would be only one of many guiding influences. The massive object that targeted 3I/ATLAS could have been an agent of that structure or merely an expression of it. Distinguishing between those possibilities proved nearly impossible with existing tools. Still, research proposals multiplied, aiming to probe deeper into the dark between stars. New telescope arrays were designed with sensitivity not just to light, but to coherence, alignment, and temporal consistency. Funding committees approved them cautiously, framing the goals in conservative language. But among those writing the proposals, the motivation was clear. They wanted to know if what happened could happen again. Public interest ebbed and flowed, reignited occasionally by sensational headlines that hinted at secret knowledge or hidden threats. Each time, official responses emphasized uncertainty and restraint. No danger had been detected, no evidence of hostility found. Yet the absence of danger did not equate to the presence of understanding. That gap continued to unsettle those who had glimpsed the raw event. Some scientists reported a strange inversion of curiosity and fear. They were less afraid of catastrophic outcomes than of the possibility that humanity simply does not matter in the grand scheme. If vast processes move through the galaxy, selecting objects and paths for reasons unrelated to us, then our narratives of centrality falter. This realization did not diminish the value of human endeavor, but it did recontextualize it. We became participants in a much larger story, one not written with us in mind. As years passed, 3I/ATLAS was last seen slipping beyond the reach of even the most powerful instruments. Its altered trajectory carried it into regions that would remain unobservable for generations. Whether it still carried traces of the encounter was unknown. Whether it would ever be engaged again was equally uncertain. What endured was the change in mindset. Students entering astrophysics programs after the event took for granted that the universe might be interactive in subtle ways. They asked different questions, designed different experiments. Instead of assuming isolation, they tested for relationship. Instead of randomness, they searched for pattern. In doing so, they honored the most profound legacy of the encounter. Not the fear, not the speculation, but the expansion of possibility. Something massive had appeared, acted with precision, and vanished. It did not leave answers, but it left a challenge. To look deeper, to question assumptions, and to accept that some forces move quietly, indifferent to our expectations. The darkness beyond the stars was no longer empty by default. It was a space of potential, of motion unseen. And somewhere out there, beyond the limits of our instruments, whatever targeted 3I/ATLAS continues on its way. Not waiting, not watching, simply moving according to rules we have only just begun to sense.